So, I've looked online and I can't find anyone else who's done this. Well, I can, but it's not really up to my pedantic standards. So, I'm going to call these the true pentagonal numbers. So, what these are is get your words out, mate. What happened was, at school, we did what's the sum of two triangle numbers, and it was square numbers. So I thought of, hey, what about pentagonal numbers? And so, after about a week of trying to figure out what there would be, I come up with a solution. And I look online and see, oh, there's already a set of pentagonal numbers, but they are not true pentagonal numbers to my pedantic standards. So, square numbers. 1, 4, 9, 16, blah blah blah. But the most important thing is, they're not very visible. So the most important thing is, they can be described as a square of dots with no gaps. So, pentagonal numbers on the other hand, like 1, then it's 5. Can you spot a problem? Actually, no, I'll do these all at once. I'll do the first 3 in different colours. So I'll do red, orange and green. So red. There's 1. That's the first pentagonal number, yeah? Then number 2. Second pentagonal number is 5. So you add 4 on top. The next one is 12. So that goes out again. That goes out again. And then this comes out. And again. And then that goes up. And up. And up. So, anyone spot a problem? Hint. So there's gaps. There's a gap there. There's a gap there. And there's a gap there. That's 3 gaps. That's got 2. The second one's got 1 gap. The third one's got 2 gaps, and so on. So as you go up, the gaps become more and more prominent. So I thought, yay! My standard, which I made up before I knew of these, is better. So first one, number 1, is just 1. Same. So 1. Next one is so you make a pentagon around the outside. No gaps. So this one is 6. Yeah? And the next one, you make another pentagon around the outside. So that adds 1, and then put 1 on either side of that, 1 on either side of that, 1 on either side of that, and then you put another at the bottom, so all the sides have an equal number of dots. So that, if you count, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah? So this is 16. And I'm just going to write down the first 6 because that's all we need for this. And we only need 4 to be honest, but next one is next one's 31. The next one is 51. Then the next one is 76. So, I thought, hey, I'll try and come up with a formula for this, because 6 isn't really that many, and I wanted to know on a wider scale what they were. So, then I saw, and then I decided to go, what if I add those, how do you get from that one to that one? It's plus 5. From that one to that one, it's plus 10, plus 15, plus 20, and plus 25. To get from then, you go 5, plus 5, plus 5, plus 5. So, you find the stop here. And I thought, oh, let's work out like n squared or n cubed or something like that, or n to the power of 5. But no. After a lot of working out, and some symbols, which I'm sure I'm not supposed to know yet for my current level of math, but I watch math things on YouTube because I'm a nerd, or geek, or whichever one it is. So, the formula is this. From 1 to n, and it's a simultaneous equation as the formula. P, for pentagonal number, equals P, as in, but that's the previous one, that's what it's already been set to, because of that. And I don't know if that's how that works, but if not, I'm going to add, if it's not right, then it's just make up a that's what I'm taking it to mean. So that, plus 5, and in brackets, a minus 1. And what a is a is equal to x, where x equals 1 to n. So if we work out this formula, so P, so for the first one, P starts as 1 and A starts as 1. Yeah? So P equals 1 plus 5 A minus 1. So that means it equals 1 plus 5 add 0, which means that it equals 1. Yeah? So for the second, keep on putting S2 second, you P equals 1, because that's what we got last, but A equals 2, because it's the second number. So that is P equals 1 plus 5, 2, that should be 1, not A. 2 minus 1, so P equals 1 plus 5 times, that's not plus, that's times as well, 5 times 1, which is just 5. So P equals 6. So first one we got 1, oh look. Second one we got 6, oh look. The pattern is coming out of this. So for the third, P now equals 6 and A now equals 3. Just gonna have a drink of water. So P equals 1 plus 5, 3 minus 1, which is 2. So that equals, no, that's not 1, that's 6, because P equals 6. Sorry, I'm making mistakes all over the place. So 6 plus 5 times 2, which is 10, that's 16. Oh, look. And this carries on endlessly. So, that means that, let me just go get my calculator. That'll be 2 secs. It's just done a different bit of the room. If I get my calculator, then I can work out the 100ths. So, the 100th No, I'm going to work out the 7th, because then I'm going to have to work all the way up to 100. Should I do 100th? Yeah, I'll do 100th in a time lapse. So, yeah. I'll be back once I've calculated the 100th. Took me about 2 minutes just to get up to the 10th, and can't be bothered because it'll get stupidly big, because the 10th one is already 251. And the way I was doing this is I was just doing it on my calculator, and then at the bottom here I just write down the values. So at the bottom, which now this is showing the bottom from here all the way along, I am going to write the first 10 true pentagonal numbers. So it's 1, 6, 16, 31, 51, 76, 101, 131, 166, 206, and 251. So, everyone, that is the true pentagonal numbers, which the formula for is just here. So from 1 to n, p equals p, which has been already set in the last step, plus 5 to the a minus 5 times a minus 1, and right at the start p is set to 1 because 1, but only the second p. The first p you figure out to be 1, so it could just be you set p to 1 for the first one and then go from there, or not. Simultaneously, x equals what? X equals 1 to n and a equals x. So yeah, this is the pentagonal. This is the true pentagonal numbers, and I think I just underlined something that you can't see. There we go. True pentagonal numbers.